If you already understand the similarity measurement, one of the similarity measurement is person correlation. We also learn about the person correlation. When we use the person correlation, it means we are using the rating for every user in the particular item, and we use the average of that users. So if we want to see the similarity between user A and B, so we will check for every rating in the particular item of that user. The possible similarity values, it will be between -1 and 1. In this case, we can look whether the similarity is about the positive or negative. If the similarity is high or is closer to 1, okay, it is the positively similar. But if it is nearby 1, but if the similarity value is -1, is nearby -1, then it is close to the negative similarity. Or it means when your user give 5, then the other user may give the opposite. So that's the meaning by the -1. Now we have this table. So let's look back on this table. I want to know what is the rating of Alice. I want to predict the rating of Alice in the item 5. I know that user 1, user 2, user 3, user 4. Let's assume we have a complete rating like this one. And I know that user 1, user 2, user 3, and user 4, they already give rating on item 5. Okay. So this is the assumption. No missing value here, and also no missing value here. When you have missing values, of course, you need to handle with different approach. Now I'm going to look at the average. Let's figure out the average of A. A means Alice. The average of Alice's existing rating is 4. How we can get 4? We have one missing value. So we do not calculate this one. And the other thing is, we want to predict item 5. So we do not consider item 5 when we calculate the average. So the average of Alice is 5 plus 3 plus 4 plus 4 divided by 4. Okay. What about user 1? The average of user 1, the same with Alice. We just consider 3 plus 1 plus 2 plus 3. Even though there is a rating in the item 5, but we do not calculate the item 5. Because later we will use this item 5 to predict this one. Okay. So we just want to know that the user 1 give rating to item 5, but we do not use for the calculation. So this 2, 4 will be from the 3 plus 1 plus 2 plus 3 divided by 4. Now, using the Pearson correlation, I think we already learned from the previous section, we can measure 5 minus the RA. RA means this average. So the item 1, which is 5, minus the average, multiplied by 3, which is the rating of user 1 in the item 1, minus the average. The second one, we have the rating for Alice in item 2 minus the average of the rating multiplied by the rating given by user 1 minus by the average. And then next is item 3, 4 minus the average of user Alice, and then 2 minus the average of user the user 1 average rating. And the last one is 4 minus the average of Alice and multiply by 3 minus the average of user 1. We will divide this one with the square root of particular user. So the first is from the Alice, so 5 minus RA, 3 minus RA, 4 minus RA, and 4 minus RA. Okay, so I missed this one. Okay, 4 minus RA. And then this one is 3 minus RB, 1 minus RB, 2 minus RB, and 3 minus RB. I'm sorry. This one, it should be 4 minus RA. Okay. Later I will upload again to the class for this revision. If we calculate this one, then we will get the value is this one, 0.85. Now, is this value high or low? High. Okay. If the value is nearby 1, then it is high similarity. So using the Pearson correlation, then I can look at this one. The similarity of user 1 and Alice is 0.85. What about the similarity of Alice and user 2? Yeah, you can calculate by yourself later. So the similarity is 0.7. The similarity of Alice and user 3 is 0. And the similarity of Alice and user 4 is minus 0.79. Now, if you look at this number, which one is closer to Alice? User 1 and user 2. Of course, user 3, yeah, we cannot consider because the value is 0. But what about user 4? It's minus. Okay, so yeah, we can say it has a negative similarity. So if you look at the numbers, when Alice gives 5, the user 4 gives what? 100. Then when the Alice gives 3, the user 4 gives 5. When Alice gives 4, is 5, and when Alice gives 4, yeah, this is also again different. So that's why yeah, the number is negative. We can see this kind of similarity using visualization, like this one. So we can look at the behavior of users when they give the ratings on particular item. But this is a visualization for only 4 items. Okay, when you have your products, it is, you know, maybe you have 1,000 products, 10,000 products. It is difficult to see with this visualization. But what I want to say about this visualization, let's look at Alice, user 1 and user 4. We can compare the similarity values and the visualization. The Alice is blue color and the user 1 is the green color. If you look at the pattern or if you look at the behavior, okay, the behavior of Alice when Alice gives the rating is similar to the behavior of the user 1. So the similarity looks like this one. So using the person correlation, the person similarity, we can see the similar behavior when the user gives rating. If we know the similar behavior, then we can predict with the similar value. But when you look at the Alice and user 4, the behavior is totally different. That's why the value is negative. So this kind of person correlation rating, yeah, it works well in usual domains. In usual domains means, yeah, just like movie, or sometimes we purchase some items. It works well. There's another alternative measures. Yeah, we can use the cosine similarity, one that we already learned. With the cosine similarity, of course, we can also calculate this one. And yeah, later we will check with the cosine similarity. So with the person correlation, you can look at this visualization, how similar their behavior. You can see this is the rating, okay? The y-axis is rating. After we have the similarity functions, we want to predict. Okay, how we can predict? It is a common prediction function we have the prediction A comma P. So A is the user and P is the product. So I want to know, in this case, I want to know what is the rating of Alice in the item 5. The formula will be RA, it is the average, plus this one, the similarity of AB multiplied by the RBP minus RB, and then we will do the sigma divided by the sigma of similarity A comma B. Maybe it is not easy, okay, to understand this formula. Let's look at later the example. So the idea is calculate whether the neighbor's rating for the unseen item I are higher or lower than their average. And then combine the rating differences, use the similarity with A as weight. So I know A is Alice. So I want to check any users that are similar to Alice. If the users are similar to Alice, so I want to know whether the user will give the similar behavior with Alice, like the positive, or the opposite behavior of Alice, which is negative. That's why we can have higher or lower. Okay. Add or subtract the neighbor's bias from the active user average and use this as a prediction. So let's see. We can make the prediction. First, the prediction for Alice rating for item 5. Okay, the prediction for Alice rating for item 5. And we need to determine who is the near neighbors. What is the near neighbors? Neighbors. You. Okay. So who is the user who are near by Alice? And we already know that user 1 has the similarity 0.85. User 2 has the similarity 0.7. So let's look at these two users as the near neighbor. If you want to choose 3, is it possible? Actually, yeah, it depends on your definition. What is the threshold or the similarity value and etc. I will explain more later. But now let's just use 2 users that we think they are similar. So we know that the similarity value is 0.85 and 0.7. So the average rating of Alice is 4. Then we put 4 plus, okay, I just put the denominator first. This is 0.85 plus 0.7. This is the similarity value of Alice and user 1. Okay. This is Alice and user 1. and this is Alice and user 2. So I do the summation 0.85 plus 0.7. What about this formula? This formula means the similarity of Alice and user 1, which is 0.85, multiplied by RBP. RBP is the rating of that user for the item P. What is the item P? We want to predict item 5. And it is the rating for item 5, which is minus by the RP. What is this RP? The average of that user. So the average of that user is 2.4. Okay. After we have this one, this is the similarity of Alice and user 1 multiplied by the rating of user 1 minus by the average of user 1. The average of user 1, which is 2.4, it is the 3 plus 1 plus 2 plus 3 divided by 4. Okay. So we get this 3 from here, and the average of user 1 is 2.4. Now we have another user. Okay, this is the user 1. We have another user, which is user 2. The user 2, the similarity value is 0.7 multiplied by 5. This is the rating from user 2 minus 3.8. What is 3.8? It is the average of rating of user 2. So we have this 3.8 here. Okay. And you can just calculate. So I put this as 1 because just want to make sure you understand how to calculate those in this section. So we have the prediction. We can predict that Alice will give rating for item 5 and the value is 4.87. So I can put it. So I know maybe, based on these similar values, Alice will give 8.87. Okay, so I give another value for this similarity to let you know why we select this user 1 and user 2 because of the high value of similarity. Okay. Okay. So there are some issues. Okay. User selections can vary. Vary means it can be different. You can choose only one similar user. Let's say I want to choose Alice and user 1 only. That's possible. I want to choose Alice and user 1 and user 2. That's also fine. So we can have n similar users. N means any numbers. Sometimes the algorithm they mention as k and n. Okay. N means the nearest neighbor. And means the nearest neighbor. So the k means any integer value. So if the integer value is 3, then it means I would like to choose 3 similar users. If I put 5, then I want to select 5 similar users. The similar measurement can vary. Now we are using person similarity. But if you use Jakarta, it will be different. If you use dice similarity, it will be different. Okay, as you can see from the example, okay, when you use Jakarta, when you use dice, okay, maybe the result will be slightly different. The example assumes no missing value. Okay. If you have missing values, the result will be different. And the recommended items can vary. So now I assume that Alice we want to predict Alice on item 5. But what if we have another items? Not only item 5, but we have item 6, item 7, item 8. So I want to predict several items. Okay, that will be also different. And we can have issue like top n items. Usually we cannot say that, okay, I can recommend coffee to Alice, but I can recommend 5 big items, maybe coffee, ramen, or something until particular number. Because there are many items later. You can see also in the Netflix will not recommend only one movie. Netflix will recommend several movies, and Netflix want to know what movies you will see. Okay. Okay, let me stop here. Let's have a break. I will continue after the break.